Hello everyone, my name is Sarman Rongpi, and today you will be discussing with me row echelon form and reduce row echelon form. So today our topic will be row echelon form and reduced row echelon form. So this row echelon form is also used to find rank of a matrix. So we'll be discussing that later. For now, let's see the conditions on how to identify a row echelon form. So let me write it for you. So number one, all leading element of each row must be 1. So let's see an example here. Example number A. Let's take a matrix here: 0, 1, 2, 7, 0, 0, 1, 9, and 0, 0, 0, 0. Let's check for the second conditions too. Number 2 will be, if any 0 row is present, then it must be present at last. So let's write here, if any 0 rows is present, it must be present at last. Let's write the condition number 3 here. Number 3 will be, in each row number of zeros will increase. Like for the first row, if it's 1, then for the second it will be like 2 or more than 2 maybe. So let's write here, in each row numbers of zeros must be more than the previous one, than the previous row. So let's check for example number A here. So we've got the matrix, and let's check the matrix. The first leading element should be 1. So we have our leading elements here as 1 and 1. Let's check for condition number 2. If any 0 row is present, it must be present at last. So here we can see our 0 row and it's present at last. And then number 3, we have, in each row numbers of zeros must be more than the previous row. As we can see here, it's 1, then here it increased to 2, and then here it's 3, 4. So we can say that this is a row echelon form. Let's go to example number B. Let's take a matrix here of, like, say 1, 6, 8, 9, 0, 0, 1, 7, and then 0, 0, 0, 1. So let's check for this one. Condition number 1, all leading element of each row must be 1. So let's check for leading elements here. It's 1, and here's also 1, and here also 1. Can we see a 0 row here? No. So let's keep the 3, and in each row numbers of zeros must be more than the previous row. So here the number of rows of 0 is increasing. First it's 2, then here it's 3. So we can say that this 2 is in the row echelon form. Let's check for example number C. So we have 0, 0, 1, 5, and then 0, 1, minus 3, 8, and then we have 0, 0, 1, and 2. So let's check it. All leading element of each row must be 1. So let's see the third example. We have here 0, 0, 1, 5, 0, 1, minus 3, 8, 0, 0, 1, 2. So let's check for condition number 1. Condition number 1 says all leading elements of each row must be 1. So here we can see that the leading element is 1 here. Here also it's 1, and here also it's 1. But as you can see, it doesn't satisfy condition number 3. In the beginning row it has 2 zeros, but in the second it has only 1. So this is not in a row echelon form. And let's check for example D2. Let's take 0 1 6 0 0 0 0 0 and 1. As we can see here, it doesn't satisfy condition number 2, as it has the 0 row in the middle and not at the last. So this is also not in row echelon form. Now let's go to reduce row echelon form. So now let's discuss reduced row echelon form. So let me write the conditions for you. Conditions for reduced row echelon form. Below and above of leading element must be 1. That is, there must be 0 below and above. Below and above. Now let's check whether the given matrix is in reduced row echelon form or not. So let's take example number 1 here. So we have 0 1 0 minus 3 0 0 1 6 0 0 0 0. As we can see in this matrix, then all leading elements are in 1, and also as we can see, if we check this leading element here, its side and its down both are zeros, and if we check next leading element 1, here above is 0 and below is also 0, so we can say that this is in reduced row echelon form. And let's check for another example 2. Let's take a matrix here, 1 5 0 0 0 0 1 0 0 0 0 1. Let's check. Yes, we can see the leading element here 1, below it's 0, so this is fine, and the next leading element here up 0 down 0, so this is also fine. This here up 0, so yes, we can say this is in reduced row echelon form. Let's check the next example. We have 0 1 0 minus 3 0 0 1 6 0 0 5 0. Let's check the matrix here. As we can see, the leading element 1, below it has 0, so this is fine. But as you can see in the second row here, this 1, below it has 5 and not 0, so we can say that this is not in the reduced row echelon form. Now let's move on next to rank of matrix. So there are mainly 3 methods to find rank of a matrix. So let's go with the first method here. For the first method, we have to know an equation which says numbers of non-zero rows equals to the rank of a matrix. So let's check. Number 1, let's take a matrix of A. with 1 2 3 0 0 0 1 8 0. So how many non-zeros row can we see here? So this one is a non-zero, this is also non-zero, so we can say that rank of matrix A is equals to 2. Let's move on to the next example here. Example number 2. Matrix B, we have 1 5 0 2 3 0 2 5 and then 0 0 0 4. As we can see in this matrix, there are 3 non-zero rows, this one, and this. So we can say the rank of matrix B is 3 here. Now let's move on to the second method. Second method is by finding a determinant. So second method we have if determinant is not equal to 0, then rank of matrix A will be 3. But if it is equals to 0, then rank of matrix A will be less than 3. So let's find here. So we have to find the rank of matrix of A. Suppose A we have 2 2 1 3 2 3 2 1 2. Let's take its determinant. So A is equals to, we have 2, then we'll get 2 2 and 4, and then minus of 3 1 and 3. The next one we'll take this 2, and we get 3 2 6 3 2 6 plus, then we take this 1, and we get here 3 1 and 3 minus 2 2 or 4. So let's solve this one. We get 2 times of 1 minus 2 times of 0 plus 1 times of minus 1. So we get here 2 minus 1, which is equals to 1, and it's not equals to 0. So looking at this condition, we get that the rank of matrix A is going to be 3. So as we have finished this now, let's move into the next method. The next method we'll be finding by echelon form. So rank of matrix using echelon form. So let's take a question here. So find rank of matrix by echelon form. So this is our third method. So let's take a question here. E equals to, we have 1 4 8 2 2 10 minus 1 minus 2 and 6. Yes, we know that in our echelon form we need our lower triangular matrix as 0. So we have to make this one 0 0 and 0. So we have to apply our R3 is equals to R1 plus R3. We need to make this one 0. So let's write here 1 4 and 8 2 2 and 10. And if you plus it, minus 1 plus 1 will get 0 here, minus 2 plus 4 we get 2, and then 6 plus 8 we get 14. And as we need to make this 0 also, so let's apply another application here. R2 equals to, we have, let's say we take minus 2 of R1 plus R2. So here we get So here we get 0, and then we get -2 of R1 plus R2, so we get here -6 and -6. Now we also need this to be 0 here, so let's take R3 equals to, if we divide this by 3 and then add it to row 3, then we'll get 0 here. So let's do R2 divided by 3 plus R3. So doing this application, we get 1, 4, 8, 0, -6, -6, 0, 0, 12. So as we can see, this is in the echelon form. Now we can apply the first method, that is row of non-zeros is equal to rank of matrix. So rank of matrix is equal to number of non-zero rows, which is equals to 1, 2 and 3. So rank of A will be 3. So that's all. Thank you guys for watching this till the end. Love you. Bye.